All right, so far we've talked about central angles, and central angles come from the center of the circle. Today we're going to talk about inscribed angles. Inscribed angles come from the side of the circle. So the vertex is on the circle. The intercepted arc, so if this is the angle, the intercepted arc is almost what's being hugged by the angle. Okay? Then you have these two words. You have an inscribed polygon. That is a polygon that is inside of a circle. So for example, that is an inscribed polygon. A circumscribed circle is a circle that is inside of another shape. So any shape, and then you fit a circle inside of it. Okay? So inscribed polygon is polygon inside. Circumscribed circle is a circle inside a shape or a polygon. Okay? Intercepted arcs are actually very, very simple. Whatever the measure of the angle is, the measure of the arc is double that. Or you could say whatever the arc is, the angle is half of the arc. Do another one. If this angle is 80, then the measure of this arc is 160. So looking at example 1, I want the measure of angle S. It's very helpful to trace the angle so that way you can see the arc that it intercepts. And then half of 60 would be 30. For the next one, RQ is here. Okay, this one you have to think a little bit harder about. RQ is not part of an angle, but there is an angle here that is 37. And so if you double 37 to get 74, you will have this much of the arc. And if you look here, this is a diameter. So now to get RQ, you're going to do 180 minus 74. So 106. If you have a little hourglass inside of here, this works out nicely because this 39 is hugging HJ, but HJ is also being intercepted by this angle. So if I double 39 to get 78, I then would have to cut 78 in half to get angle G, which would then be 39. So HGJ would be 39. HFJ would also be 39. So this theorem just says that if you have a little hourglass, ADB would be congruent to ACB. Two pairs of congruent angles in the figure. These two hug the same arc, so P and Q, and then S and R. I'll let you guys practice these by yourself. I'll just put the answers in here. Okay. We're going to cross that out. The next theorem says that if you have a circle, no matter how you draw the circle, if you draw an angle that is inscribed within the semicircle, so that's half of the circle. So I'll draw one here, I'll draw one here. Notice how these are all bound by this semicircle. No matter what happens, the inscribed angle is going to be 90 degrees. So in this one, ABC would be 90, if and only if AC is the diameter of the circle. And then for the last one, remember a shape that's inscribed is a polygon inside the circle. This one's also pretty easy, but people sometimes confuse them. When you have a polygon that is inscribed in a circle, the opposite angles are not equal to each other unless it's a square or a rectangle. They are equal to 180. So for example, if this was 80, this would be 100. If this was 120, this would be 60. These angles have no relationship to each other. Just the opposite angles have to equal 180. So for example, these two make 180, so y is 80. These two have to make 180, so x is 92. Again, these two make 180, so 8x plus 4x is 12x. 12 times what is 180? And then same thing, 3y and 3y is 180, so 6x is 180. So x has to equal, or, well, what is that, y? Y has to equal 30. And then the last one, same thing. These two make 180. So B is 21, 5A and 90 also equals 180. So A equals 15. Okay, you can go ahead and work on this worksheet. I will make sure that this is in the Google Classroom. You can also just check your answers with a partner.